So, welcome back to the Virtual Residency Workshop 2026. It is Tuesday, June 23rd, 2026. This is our third session of the day, the early afternoon session. The title of our session is How to Learn and How to Teach Research Computing Resources, and our moderator is Franklin Fanjufotu of Langston University. Franklin, go ahead and take it away.
Again, thank you, Henry, and thank you all panelists for being here today. As Henry just mentioned, this panel is about how to learn and how to teach research computing resources. Myself, I'm Franklin Funjo. I'm the director of the Computing Center for Research and Education, a small computer center. And I'm also the acting dean of the School of Art and Science at Langston University. And I've been Henry Fellow for almost 15 years now, for those who know what that means. That means today we have a panelist made of Bob, Brian, David, Jason, Sue, and you. And we all know that this team are facilitators. And as CR facilitators, you are regularly called on to understand a constantly evolving collection of systems, services, and methods and techniques. In this panel, we will look at mechanisms for learning these resources and how to teach them to researchers. We will start the panel by letting the panelists introduce themselves. I will start with Brian, please.
Hi, my name's Brian Moore, and for many years I was a HPC support person at South Dakota State University. And prior to that, I taught chemistry at a couple of different small colleges. Around 2019, I transitioned into a job at a defense contractor named BAE Systems in Minneapolis, and I do HPC support there and a lot of other stuff. And they don't let me out very often, so I'm really glad to be in this meeting. Also, by the way, Pierce is in Minneapolis this year. They are going to let me go there. I really appreciate the chance to network with people, so I'm really glad to be here. I would say my perspective is going to be a little different because it's very different here, but it's still the same.
Thank you, Brian. Next, David, please.
Thank you, Franklin. Thank you, Henry. I'm David Reddy. I'm a research facilitator with Research Computing at the University of South Carolina. I run our workshop series, and I also host various training sessions. For instance, the Access workshops offered by the Pittsburgh Supercomputing Center. And we also present some of the NVIDIA Deep Learning Institute workshops. I've been a research facilitator for about 6 years ago, and for about 6 years, and I've been in academic computing for about 40 years. And I work closely with my colleague Bob Doran, who's a research scientist with Research Computing. So I'll let Bob introduce himself.
Thank you.
Yeah, good afternoon. Bob Doran. I'm with University of South Carolina. Been with the Research Computing Group for about 12 years. I'm both system-facing and researcher-facing. We have a few different clusters on campus, some for teaching. The majority of ours is research. I help with both architecture and getting users' applications running, and help them with getting it, using the resources efficiently, and teaching them how to what to look for, and try to get them as independent as possible. And that's about it.
Thank you. Well, Jason.
Hi, good afternoon, everybody. I'm Jason Sims. I'm the Research Computing Manager at Swarthmore College. and I've been in that role for about 3.5 years now. Prior to that, I did a similar role at Lafayette College since about 2016, and that represents about the length of time, so about a decade that I've been involved in research in high performance computing. And I've also been involved with the virtual residency and all of Henry's undertakings for about that same amount of time. So very happy to be here.
Thank you. Sue, please.
Hi, I'm Sue. I'm from Webster University. We're in St. Louis, Missouri. So I'm not a research facilitator. I'm a professor of computer science. So I in my courses, I do teach high performance computing in my courses in undergraduate level. Um, I am a co-PI for the CC Star grants that we have. I'm also the PI for some educational grants. So my experiences are mostly working with students directly.
Thank you, Sue. Yui?
Hello, everyone. My name is Yue Yu, and I'm the Senior Research Computing Facilitator from University of California, Merced. I've been involved in research computing for about 12 years, and I worked as this research facilitator role about 6 years ago. And I will be participating PERC conference in Minneapolis this July, so hope to see many of you there too.
Thank you, Yui. I will stay with you and kind of start our setup question, Yui. As research facilitator, when you receive a new computing resource and make it available to researcher, what is your process to understanding the resource first and figuring out how to teach those resources to researchers? Tell us a little bit about your journey in that type of space.
Sure. That's a very interesting question. So I would take a hardware, for example, as a GPU as example. So when we got access to a new GPU partition, my previous experience in academia was I used to be a computational chemist. So what I normally do is I throw something that I'm very familiar with to the hardware, for example. So I run some small molecular dynamic simulations on that particular GPU to try to get more familiarized myself. And I normally treat that particular hardware like a new lab instrument so that I don't normally read manual, but I actually run some known samples to see what comes out of it. And for researchers, I flip the process. For example, I start to ask them what's their science. And I will normally ask them, what are you running on that particular hardware? And what does the typical job look like to see whether that particular hardware will suit for them so that it will be easier for me to learn their particular science and try to teach them what particular hardware that is more suitable for them to run.
Thank you very much. Bob, your experience, please.
Yes. So similar when we get new hardware, I do probably a few different approaches to get familiar with it. I look at I do some Google searches to see what the expected performance gains are. I'll often download some containers from NVIDIA and do some comparisons on old hardware versus what the new hardware is. Um, we did have a fairly was our MRI cluster about 2 years now. That was a grant funded cluster that we got. Um, it probably would have been good to have a formal training for the new cluster, but um, we introduced we also added accounting on that system, which kind of forced users when they had troubles to reach out, and then when they reached out to ask why their jobs weren't running, we kind of jumped in and did a little one-on-one. Okay, this is what the new hardware is. These are the changes you're going to need to make to your scripts, and then kind of monitored like I don't know, one-on-one kind of basis how their jobs are doing and make sure things were running efficiently.
Thank you. Thank you. Jason, tell us a little bit about your experience in this space.
So I think I'm going to have a slightly different perspective than I think other panelists, which I guess is a good thing, right? For variety. Swarthmore College and Lafayette College both are very small, highly selective undergraduate only colleges. And that experience is going to color, I think, a lot of my input to this panel. And in this particular case, what it means, unfortunately, is that any researcher's project or work or any student engagement, they're all one-offs. And I say that because there's just really no overlap in expertise. And so what that means is that from a training perspective, it's very challenging for me to come up with something that is generic and holistic enough that I can provide it to the community en masse and have that be particularly useful. So usually what I have to do is I have to meet, and I have the luxury of doing this. Folks from larger R1 institutions, R2s, industry may not have this ability, but I have the luxury that I know all of my users. So anybody who's using our hardware, our equipment, our service portfolio, I know them all and I know what they're doing. And so that gives me the ability to meet with either an individual researcher or students or sometimes a lab group or whatever, or I'll go into a class. And I'll be able to onboard them to whatever the new resource is in a way that makes sense for their workflow and their use case. So it does unfortunately mean that I have to, kind of approach each training session very differently. I can't just kind of be generic about how I approach it. And for some people, that's just a impossible luxury. But for me, that's actually feasible. But it's also more challenging because I have to understand how all of this new hardware is going to be, kind of poked and prodded at by various different use cases, various different disciplines, some of whom don't resemble any one of the others. So it is a lot of work, and that's also harder when, like I think some of us, I also don't have the luxury of having a lot of FTE. I'm it. So when it comes to research computing support, facilitation, system admin, it's myself. I have a sysadmin who can help, but he doesn't do a lot of the facilitation per se. So it is a lot of deep dives, and it's a lot of getting to know what they're doing, asking them what they want to accomplish, and ensuring that, I can help guide them and onboard them in appropriate ways.
Thank you, Jason. Interesting. Sue, I know you said you are more student facing, but still we go through those same experience. Can you please share your experience with us?
Yeah, so we don't have as many users as some of you guys are describing. So I feel like I'm the least experienced person here. So so I have to be a user before I become an instructor, right? So usually what I do slightly different from everybody else because I'm the instructor. So I usually pilot my project with a few students. So I do have a few research assistants. So I usually pilot my what I think like an end-to-end workflow, so which I create by myself. So I usually pilot that with my student assistants. So and afterwards because my focus will be teaching, right? So usually I also do is I make some teaching materials. I do have some teaching materials on my GitHub. So I work through the teaching materials like, by myself first, and then I show to the students and make sure they're doable. So then I show to my class. So then I receive feedback from my class, right? So then I refine those teaching materials and, so on and so forth. We don't have a lot of users for sure. So our users are mostly undergraduate students or a few other faculty members from the science school. So I also ask around, right? So I say, what are your pain points? I don't know if that's the right terminology here. So what difficulty have you had? So sometimes people would give me some feedbacks. So since most of our students are undergraduate students, so the questions are more towards, things like, how do you do this? How do you do that? So I would say I'm the least experienced person here, so I haven't had a situation where they're asking a question that I just could not answer because they're mostly undergraduate students. So anyway, so that's what I do. I try not to teach features only. I try to teach the workflow more than just a single feature.
Thank you very much, Sue. Brian, please.
Yeah, my experience is very, very different. I've been here 7 years, and it's really been an evolution. One of the things is like we really don't do research; we do production. And when I think about that, I think when I was a chemist, we used to go in the lab and we'd put in the GCMS and it had this like 128 sample carousel. It seemed crazy, right? But then we visited a production company in town and they were running 24/7. Very, 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 very similar samples all night long, collecting the data. That's kind of what we do. So when I first came here, I was kind of really gregarious, wanted to really, dive in, and it was really interesting. I mean, everybody already knew what they're doing, and they were already doing it. It was already working, and I kind of had to just sort of. And the other thing is, they charge their time. Their time is extremely valuable, and everything goes to a contract, and is basically driven by a deliverable. So I kind of just had to sort of sit back, and it took a long time to even understand the company, how the company works. It's a very large company, and for instance, we have a team called Unix team. I found that very strange. Like it's like a whole layer between me and the servers, and you can't just do things. So I guess what happened to me was kind of fortuitous, and I did the same thing at SDSU. In retrospect, is I just tried to figure out a way to be useful in the setting I was in, and that turned out to be in another area. I was assigned another application, which is a legacy application. It just happened to fail right after I got there, and I became useful, and I learned the company. I learned everything about the company. We do ticketing, we do change. It's done. You have to work yourself through all of that and understand all of that, and wait to see what comes your way. I would say now we are in a different situation. We don't really do training. We're talking about kind of doing it. We have a lot of, well, we just migrating to a new cluster. And we're trying to unwind what are people actually doing on our current cluster and document that. Because sometimes people do stuff and they don't even talk to us unless they run into a problem. So that's kind of a very chaotic answer. But I think the thing about trying to meet people where they are and also working with people who are extremely sophisticated and extremely knowledgeable about what they're doing. It's a difficult thing because you really have to just sit back and just listen because you're not going to really know much until they really tell you. And the thing I realized, when I was at SDSU, we had people like that in the mix. I don't know that I served them very well, and so maybe that's something to consider, as you have a mixture of users. Sometimes when you're in a university setting, you tend to give all of your juice to the new people and stuff because they need all the help. But somewhere in your mixture is probably some people are extremely, knowledgeable and know what they're doing. And that's kind of what we're doing. I know all of my users too, right? Uh, in fact, we onboard people to the cluster so infrequently that we sometimes run the risk of like forgetting how we did it the time before. And so I was involved in just like documenting that so that we didn't like forget from the time before. So interesting though, I just had a really good session with a researcher this morning, and he reached out to me and they're trying to use a new application and they want it to run on the cluster. And it sort of reminded me of what I used to do. But I really had to I just make myself available. I try to use the little spaces in between to chat about things and talk about things that might be, but you can't, I really have learned you really cannot, their time is committed and they have their own set of resources, of priorities and stuff. So that's kind of what I'm doing.
Thank you, Brian. David, please jump in and kind of give us your experience.
Yeah, sure. Well, I think much like Jason, I'm doing a lot of one-offs as a research facilitator. I'll be doing intake interviews or trying to get a graduate student up to speed or talking to a faculty member about the capabilities that we have. And I think like Sue, I like to approach it as almost as if I were a new user, because of course, if I come in that way, I have to explain it that way. So my approach is, for instance, as Bob mentioned, we got this new AI focused cluster. which we got through an NSF Major Research Instrumentation grant. We've had for maybe about 3 years now, we've had a research data storage resource. We also have an on-prem AI solution. So whenever we get one of these new resources, I apply for an account or an allocation just as a regular user would, and go through the whole process, log into it, um, play around with it enough to get myself familiar with it in a general way. Um, just to contrast what I do with what my colleague Bob does, he is more interested in helping people, say, optimize uh, their workflow on the hardware. My focus is more on, bringing them as new users in, explaining all the capabilities, all the resources, all the teaching elements we have. And then, of course, I also produce the documentation for these new resources. So that is another aspect that lets me familiarize myself with the resources themselves. And then a lot of my job is just kind of extrapolation, like, well, given what's in front of me, if I had the same problem that a researcher has, how would I approach solving it? So that's kind of what I'm bringing to the table, is both that broad background knowledge and the kind of resourcefulness and inventiveness to put together, um, I wouldn't say highly tailored solutions, but general frameworks for solutions.
Thank you, David. Just staying with you, time-wise and challenge-wise, what has been the most difficult research computing resource for you to learn? Tell us some story about it. Yes.
Most difficult to learn?
And time-wise.
Yeah. I guess honestly, the ins and outs of Slurm and all the ways that scheduling can go wrong, and all the effects that can happen with noisy neighbors, and um, research computing, high performance computing environments are sort of fundamentally different from other, multi-user environments, which are set up to kind of protect you from the effects of everyone else who's using the system. On research computing platforms, the whole design is to make it run flat out as fast as possible. And, sometimes the guardrails aren't very strong. So I would say playing around with the systems enough to understand when users come to me saying, oh, I tried running my job and it crashed for this or it crashed for that. I can't figure the whole thing out. Having enough intuition, enough experience, enough background in running these jobs to uh, be able to kind of point them in the right direction and do some sleuthing through the databases to and the output files to figure out what's going on. And then, helping them instrument their scripts has been a big thing I had to learn by myself the hard way, I would say.
Yeah, thank you, David.
Thank
Bob,
you.
yes. Can you add something to that, Bob? What has been the most challenging part of it for you?
Yes, um, yeah, good question. So we support all disciplines across campus. So I end up diving deeper into things I've never studied or knew much about, um, and learning it well enough to teach it. So That is probably the more challenging. I spent a lot of time reading and studying, but probably my the things we become experts on as the experts in those fields that are not from a computer background. For example, a lot of the bioinformatics workflows, and I'll often drag David into new onboarding. Those pipelines can be very long, difficult to um, move off their lab desktops to get them running on the cluster. That's usually a fairly time-consuming effort. And a lot of these researchers, they have limited students, limited time, and very little patience. So, so you have to reach out to them and give them a functional script, teach them what to, um, to change to make their workflows work for them. And it's also difficult to get them to explain the whole workflow to you. They'll give you little bits and pieces of it, and then when you go back and ask them how they're doing, they're struggling on something they never even mentioned. You're like, oh well, um, because we can help you with that as well. So it's a constant back and forth, and I always encourage the needy researchers to try to hire a student, or even we'll help them recruit a student that can work directly with us when there's challenges with the time commitments to getting running on these new systems. And as others mentioned, David mentioned, probably the biggest hurdle still with HPC is the ease of use. So I've spent a lot of time um, trying to forget everything I know, and if I came in, how overwhelming or difficult is it for me to take a new workflow and get it running? Um, so that's yeah, not a single one answer, but every new needy researcher actually helps me become more of an expert.
Yeah, great, great, great. Yes, Jason, please tell us a little bit. What is that has been difficult for you when it comes to research computing
Yeah,
research?
I mean, for us, the event that really stands out is, prior to 2019, when we brought the first cluster online at Lafayette, there was no HPC or research computing centrally managed ecosystem. And so what was hard was, sort of retraining, if you want to put it that way, an entire research community to move from either, servers under a desk or literally in a closet. I'm sure we've all experienced that, personally owned devices, research lab stuff to going from that to a centrally managed and supported system. Um, just like, David said, moving to a batch submission, Slurm environment from just environments where people could run what they wanted when they wanted and they owned the hardware themselves, implementing condo models and kind of figuring out procedures and policies as we go. So just not necessarily training on any particular set of hardware or resource, but introducing that resource and literally training for a mindset paradigm shift into that kind of world was very challenging. Now, some faculty, some researchers who had done similar kinds of work when they were graduate students or in collaboration with other labs made that process a little easier because in that case there we would have some ready-made evangelists, people who are like, this is great, I'm familiar with this environment, this is going to be a great thing for our community. But in general, getting used to that, going from nothing to now we have this and this is sort of how we're going to move forward and support research computing was a real challenge. And in some cases it still remains that, there's still that kind of vestigial desire for control that you give up to a certain degree when you are using a centralized system. Um, and I think also, finally, a challenging element of that is most of us know that when you build a centrally managed, particularly on-prem environment, You generally do not or cannot build it to support 100% of your use cases. That's often impossible. 90% of your time, effort, and resources would be spent trying to get that last 10% kind of covered with most on-prem systems. So we aim for about a 90% coverage when possible. And so what that means is it is often hard to then identify to cover those edge cases what environment's going to be good for that, and how do I learn and onboard and integrate that workflow with what we have locally. And so that can be also a real challenge. So, trying to identify and accommodate those 5 to 10% of workflows that don't really have a great analog locally, or even one of the more common extramural resources can be a real challenge.
Thank you very much, Jason. Yui, please tell us a little bit your experience at NICET.
I think the most difficult research computing for me is resources for me to learn is that it's not a particular tool or particular software, is the transition. Like many of you here, I used to be a computational chemist, so I was a user. I am a HPC user still now, but suddenly transition to a role on the other side to be more responsible for keeping the system running and up. So early on, for example, we had an incident campus-wide that all the users just couldn't log into the cluster, and something that I never dealt before. Because as a user, if you have any problem, you just submit a ticket, and someone else will solve the problem. But now, being a research facilitator with some system administrator responsibility, you are the ticket. You have to be responsible to solve the problem for the users. So when the campus-wide incident happened, at that time, I have to diagnose the problem, coordinate with my colleagues, work towards the fix. And like Bob mentioned, a lot of users, they have no patience, right? You have to give them the solution right away in a timely manner. So you have to work under some pressure to solve the problems. So I think the transition is the hardest for me from the user to the other side, become a facilitator, become system administrator. So the responsibility shift quite a bit. So the mental shift is quite challenging for me.
Thank you. Yes, Sue, please. What's that piece?
Yeah, so I've been listening to everybody. So what's most difficult to learn? You were saying, so are you talking about students or are you talking about, so
No.
if you're talking about students, for instance, right? So um for my personal experiences will be it's kind of funny. So students don't realize, jobs that run locally probably wouldn't work on the HPC cluster. So one of the most common mistake they make is they see something called a module not found error from a Python script. So they come to me and they say, why isn't it working? So, it's a very common mistake, right? So there's nothing wrong with it, but it's the single most common question I was asked. So I guess the most difficult thing for me to learn will be working with students and do not have expectations that um, so mostly of our students are undergraduate students, right? So I guess, understanding, there's a need to teach resource allocations, need to teach not just command itself, but also teaching environment modules, virtual environments, dependencies, so on and so forth, right? So um, the probably that takes a long time. So I would say another thing that's difficult for me to learn is I usually plan for in the very beginning, I planned for like one module talking about HPC, talking about Linux, as a whole. But then it's never enough time because students would run into different issues, right? So that brings a new topic, right? So that brings a new topic, right? So that adds on. So the time is never enough for me. So I think the very difficult thing for me to learn is the managing the teaching time. Dealing with undergraduate students, you have to be very patient. You have to be very um, diligent or being very careful planning all the details. So anyway, so I usually tell students, right? So Linux isn't just a single, HPC isn't just a single Linux. It actually requires a different way of thinking about computing resources. So, so that's for me that I don't have a lot of experiences working with more advanced users. I do have one time we had a computational chemistry professor who was asking some questions and I wasn't able to answer. Later on I thought about his question. I did not give him a solid answer. I don't have any other experiences working with biology or chemistry or physics. So I think those are areas for me to explore later on. Yeah.
Thank you very much. Brian?
Yeah, I guess good answers. One thing that has hit us is it's just dealing with the company. And we'll have, I told you, we have Unix team and a larger company that manages things. And I was gonna say, I swear Puppet drives me crazy because we have our cluster and we have our system guy and he runs Puppet fine, okay. But like, for example, he did this thing where he allowed me to get root on all the nodes and that was good. Like in the middle of the night, if I need to do something simple, I'm not the system guy, but he's like, okay, this thing has gone south, you could do it. But we lost that and we couldn't figure out why. And we get a Unix team on, they go, well, I think there's another Puppet running against your service nodes, and they couldn't even find it, right? So that was kind of an interesting thing that we have to do. The other thing I guess I'd say is that one of the things that frustrates me right now, maybe this is not really, but just something I'm thinking about, is that we don't do stuff that we don't need to do right away. And I think normally in an HPC setting, if you stand up a cluster, you're going to run stuff just to exercise the cluster, or maybe to look forward. Say, hey, there's something that no one's asking for, but maybe we should be playing in that area. Well, so we don't have any GPUs. We don't do any AI. We don't do any training. And I'm trying to make that case. And then I guess it's a more specific, I kind of have this as a question. Maybe if somebody, sees me at Pierce, you could come up to me and tell me, when we set up a cluster in South Dakota, at least the first one of the things that I did that forced to happen that was really useful was we ran LinPack. I know LinPack's kind of old, but this was 10 years ago. And that just was useful. It makes sure the whole stack is working. Maybe it's not perfect, but it exercises the entire cluster, at least gives you some sort of sense that it's all working. And we don't do that. And I worry about that. And I don't think LinPack would necessarily be the thing you would want to do now to do that same kind of thing. Maybe it would be training some AI model. I mean, again, if you don't have GPUs, you're not doing that either. But that's very frustrating. We tend to just attack an exact problem for an exact set of users. Once they have their solution, they're kind of like, well, why don't change it now? So that's been probably one of the more difficult things to try to deal with.
Yes, Brian, if we think about that, and think about teaching, what has been the most difficult research computing resource for you to actually teach someone? And Jordan said the same way, the story about.
Is that to me?
Yes, Brian.
Yeah. Well, I guess that part of the problem is we don't do any teaching, but we do a little bit and a little bit more and more. And I guess the frustration we've had is teaching anything at all. And then the other frustration is we find out there's groups of users that actually have taught themselves a tremendous amount of stuff, and maybe they've even documented amongst themselves, and we didn't even know about it, right? And so it's sort of, like I told you, the thing at the beginning, I wanted to be very gregarious, like Henry's my role model, right? And go out and, meet people, and that just was not the right thing to do. So, yeah, that's, tell me the question again. I've wandered off here.
I mean, teaching.
Oh, teaching.
What has been your challenges in teaching?
I guess the challenge has been it's the same challenge I think it always is, which is to try to just explain to people what a cluster is. And I think I have some skills in that area that I learned over the years. You try to really just boil it down, and like just yesterday, I am from somebody, and he's running like some FEA program that runs on and on and on, and he wants to know how to restart it. And I go, well, yeah, I'm in the middle of a meeting. But then I told him, I mean, you look at the bottom of the script. That's where all the juice is. Yeah, everything else is, oh, by the way, our cluster was stood up by a contractor. And the contractor wrote template scripts for all of our applications, but they're just full of noise. You know what I mean? So if you look into our old Moab scripts, they'll be like, 100 lines of stuff, and they have to go all the way down to the bottom to really realize, oh, that's where Abacus is actually running. And I think he figured his thing out. But it goes to that, yeah, we have difficulty teaching anything, but I think we're kind of getting, what's happening now is we're getting all into teams, and everybody is a team now, Microsoft team. I don't know about you if you're in a Teams environment, but it just overwhelms you. But I'm thinking that in that environment, maybe we can do some new things, just to get the general. Oh, the other thing is if somebody comes to me and gets on board, more and more, I use that as an opportunity, especially if they're a younger person or a new person, just to say, you got any questions? Like, hey, do you want to just like run a job? And I do that more consistently now. So at least people get a sense, and I tell them, this is the question, this is how it works. You're gonna run on a node and all this stuff. So it's very difficult, but you have to make progress in the environment you're provided with.
Yeah, thank you. Yes, Sue, please tell us a little bit about the most difficult research computing resource you have thought and your story about it.
So again, I teach at the undergraduate level. So things that we see here might be different, from a more mature researcher. So I teach performance engineering. Performance engineering, I do not teach, this is my mistake. I do not teach in the broader level. I only teach in the parallel version of performance engineering. Performance engineering is a very broad area, right? So I would say the most difficult thing to teach, not difficult, most observed question or concerns are, students basically expect, if you're using more cores and then the program should run faster, right? So, and then there's a scaling limit, right? So I usually have to go on to talk about, memory bandwidth, there are some bottlenecks, there are some other laws that you have to be, but teaching these concepts are very abstract. So unless they're really running into that issue, they don't necessarily see that being a problem. So especially like, memory bandwidth and also the different laws. So what I've been doing so far is using some existing AI models and to train, AI model trainings so therefore they will eventually run into an issue for scaling problems, scaling bottleneck problems. So I feel like teaching through AI model training will make these concepts more tangible. So anyway, basically what I learned from here is using real applications to teach performance is probably better than, just talking about benchmarks. So anyway, and also what's the most difficult resources to teach for the researchers? I don't have a lot of experiences with that. I'm just a professor, so I would say that one more time. I don't have any expertise in biology or chemistry or physics, So I have had situations where people ask me a question from the chemistry side, which I wasn't able to answer very well. So I don't know how other people deal with this. I would assume, different teams, they would have different experts, in different science fields. Right. So yeah, so that's me dealing with students. And also, like I mentioned before, sometimes I do run out of time because there's just too many things to cover. So that's also, something else.
Thank you very much. Good answer. Let's jump. Yui, please tell us a little bit, just for us to get one more answer to that. The most difficult research computing resource that you have thought, and share your experience.
Sure. I think in terms of teaching, I think the hardest part is to find the right content to the right audience. So we have two levels of HPC training, a basic workshop and an intermediate level of the workshop. So a lot of times that some of the users who have some little experience and they walk into the basic HPC workshop. They think the content may be too basic for them. However, considering the diverse background of different users, right? You cannot design a content to feed them all. So the basic or intermediate, the concept towards different people, it has a very different meaning. So the deeper challenge for teaching for me is to really adapt to this genuinely diverse background of the student or audience. So as a computational chemist, for example, who run jobs daily, they maybe feel more comfortable to go to the intermediate session compared to a humanity researcher who rarely log into the HPC, and maybe they just log into the HPC once per month and process some data set. And they go to the intermediate session, they may think the intermediate, it just means something a little more basic. So a lot of times they cannot follow the pace of the examples that we do during the workshop. So I think the challenger for me to teach is to how to set the expectations right up front so that the users can self-correct them while along the way while they were start learning during a workshop. So that's what I learned in terms of how to teach the HPC training materials properly towards a diverse background of audience.
Thank you, Yui. And I will try to move forward here. But please tell us instead when, for instance, to help our Bob, to help our audience here understand your daily work and your life in that at that position. You have made some mistakes, right? And we say never reinvent the wheel. How can we help the audience here learn from that mistake or from your own mistakes um, and so that they don't do the same mistake? Then tell us what is the dumbest mistake that you have done as of now, Bob. Thanks.
Start from me?
No, Bob.
Oh, okay.
The dumbest mistake. Huh. Where to start? There's so many. I gotta think about that one.
Okay.
I guess a lot of it does revolve around user expect. What do I expect of the users? When you go from a workshop or an introductory session, and the whole time during the workshop they're agreeing, yes, everything's fine, understand perfectly, and then they'll call you tomorrow and they didn't recall anything. So so just be careful of I guess that's probably our biggest challenge is um just when the users agree with you, it doesn't mean they can actually be successful at running their jobs. So it's just making sure you loop back and try to prevent that frustration level from losing people losing interest in taking advantage of the power that's available to them.
What have you learned from that, Bob?
What have I learned? I've learned to interact more closely with the researcher and make sure to follow up and physically go look at their queues. What have they got queued up? What's running? Um, Go to the node and see what is going on with their job. And yeah, so more be more observant and not be so. Um, Here I taught you everything I know. Not be dismissive of the researcher and what they need to do.
Yeah, great answer. Thank you, Jason. Please tell us that dumb mistake that you made in learning and teaching research computing resources.
Yeah, I mean, I think I'm going to take a slightly different tack on a response, because I've done a lot of the same things that many of us have done, executed a command on the wrong directory, things like that have led to disastrous consequences. But I think from a teaching and sort of mentorship perspective, two similar but related things. I think when we're communicating with researchers, particularly those who are learning, um, one of the mistakes that I made very early on when I was developing my kind of skills as a research facilitator was responding in ways that would say things like, "Oh, it's so easy. All you have to do is this." Well, you don't want to use that kind of language because to some people it's not necessarily easy, or it's a very different mindset or concept that they've never been introduced to. And so saying things like that, especially if they then struggle to get it, can really kind of make them feel bad. And they're like, well, what is wrong with me? Like, why don't I understand how to do this? Like, this really isn't easy for me. So that can really put them off. Or the sort of related flip side to that is when you're talking to someone about their workflow and they tell you how they're currently doing it. You kind of have to have a poker face because sometimes you want to say things like, "Oh, you should never do that," or "That is not what I would do," or something like that. Even if it's often true, you want to be very careful as a educator and as a research facilitator, not to react in ways that make people feel bad or that they've been doing something wrong or they're making bad choices or that it should be easier than what it may be for them. And so learning a lot of that, and those are the kind of things that people will not often tell you to your face. So you may not get that feedback yourself. You'll just think that you had an interaction with somebody, you thought you were helping them out, you provided them guidance, and then you never hear from them again. And so from your perspective, you think things are going well. Meanwhile, they tell a colleague of yours or your supervisor or something like that, that maybe that interaction wasn't quite as pleasant as you thought, and maybe it left a bad taste in their mouth. And so they're not using the service, they're not using the platform, they're not using this new tool or whatever it is that you were trying to onboard them to, because that experience was not as positive and as supportive as it should have been. So for me, that those were the kind of early mistakes that I was making from a communication perspective, that I think we all have to develop in our roles as facilitators and educators.
Thank you very much, Jason. Have you learned anything from that?
Well, yeah, I mean, you do learn early on that when you make those mistakes, sometimes it can take a long time to rebuild that trust. And so what you learn is, not only kind of what not to say in sort of a first blush or a knee-jerk reaction, but you learn how to craft the communication really directly to the person at hand and to the use case at hand, to really just try to avoid that and to be encouraging as much as you can. And so experiences like that really do teach me and have taught me, how to communicate very effectively with the researcher community and with students especially, because students are a very delicate group. They're often excited, they're energetic, they want to try and learn new things. They want to develop new skills that are going to help them either in their professional vocational careers or in grad school or whatever. And you really want to tend that excitement and flame without snuffing it out because you're trying to be too heavy-handed with them. So those are some examples of what I've learned from those types of experiences.
Thank you very much, Jason. That was great. David, please share your own experience with us.
Yeah,
That makes mistake.
happy
Yeah.
to. I'd like to just second everything that Jason and Bob just said. They really put that together well. Yeah, the dumbest thing I did recently. So in addition to scheduling our workshop series and coordinating the workshops that are in a certificate program that's co-managed by university libraries and the graduate school. In addition to that, I actually teach 3 or 4 of the courses every semester myself. And so, we've been talking about, how deeply immersed we are in Teams and calendars and scheduling apps and all that kind of stuff. So, one morning I had a family emergency. It wasn't my personal emergency, but I had to be there for a family member. And, I thought, well, this workshop could be taught on any particular day. Um, and so, I messaged our director of research computing and got the okay. And I rescheduled it in the calendaring app and I moved the Teams app. And then, at the end of the semester, and I kind of assumed because it's so the scheduling application that the library uses is so overly uh, pushy with emails that if I rescheduled, it would just send something to, all the people who had registered for the workshop. And that they would see, they would get an email notification and see that the Teams meeting that underlies it had been moved and all that stuff. And then, we get to the end of the semester and there's this, set of qualitative comments, and they include things like, well, I showed up for the workshop, but the instructor wasn't there. This was a total waste of time, you know. Um, which, I mean, that's really a valid gripe.
Mhm.
I'm making too light of it, from my point of view. But uh, I had to own up to that basically. I had to think to myself, well, what else could I have done? Could I have ensured that they got an email? Obviously, it wasn't all going to give them all a phone call or something and say, I'm sorry, this really is a family emergency. I can't teach today. We'll do it 2 weeks from today. I hope that works for you. Um, but you just get so reliant on everyone,
Mhm.
checking their email, checking their calendar, getting the updates, and then, being flexible until the last moment. But, I mean, they're busy people too. They have
Yeah.
busy lives, and I guess I just had to own that one. So yeah, that was the dumbest thing I did trying to teach.
Thank you very much. Thank you very much. Brian, any addition, something that you did that's
Well,
uh,
I was just thinking of something. Actually, it wasn't HPC, but it was similar. Not long after I came here, I was manager of the Doors app, the IBM Doors app, and it was running on Solaris, and the disk died. And I learned a lot about the company. What happens is it was about late in the afternoon, and then you get on a call, and more people join the call from various parts of the company. And we had something set up. We had a server like waiting, and we found the backup. I think we had to wait 8 hours. No, we had to wait 3 hours for the backup to come on. And anyhow, the Unix guy was there, and he was a young guy, part of their team, and I don't think he knew Unix very well. And he was the only one who could do it. We're watching him. And here's the funny thing about this: I know that it was a choice between move and copy. And actually, I don't remember which one he got wrong, but I do remember sitting there watching it going, oh, I wouldn't do that if I were you. And I didn't say anything. I didn't say anything. I remember thinking, that was a mistake. I saw that guy do that. And then it was like, oh man, we had to wait till the next day. I mean, it worked out okay, but it was one of those gotchas that was kind of like,
yeah, Sue, can you tell us a little bit about your dumbest mistake in
Uh,
teaching and learning those resources?
yeah, so I don't have a lot of experiences with that. I would say in terms of teaching, I think I mentioned this already. So, I actually agree with Jason 100%. So, previously when I was teaching a class, in my first time ever, I taught HPC, my undergraduate level classes. A lot of things are pretty obvious to me. So I packed a lot on the first day, which to me wasn't a lot, but when I was teaching students, the questions they were asking me and also the trouble they were running into, right? So that quickly become two more classes, three more classes. So my other content wouldn't fit anymore. So, you know, it's like I didn't try, but actually, eventually ended up explaining too much on the first day. So, covering Linux, SSH, Slurm, Python environment, modules, file transfers, that's quite a lot. So I would say, um, basically not trying to assume your users will know as much as you do, or perhaps, not assuming, what you are saying is what they're expecting to hear, and not trying to because a lot of things are really truly obvious, right? So because I'm a computer science major when I was in school. So a lot of things we learn in school, and after so long, you don't realize that something you actually learned. It doesn't come obvious, it's not intuitive, right? So it's basically something you learned, but you forgot about how difficult it was to learn. So when I was teaching the students, I realized that that's something that you cannot assume, they already understand this. You cannot say, yeah, that's obvious. You cannot say that. So you have to assume you're teaching from the fundamentals, and you have to be very patient. Um, so teaching, so when I'm working with more advanced students, right? So I only try to teach them what they need for the day's task, not trying to teach them beyond, go on and on. As a professor, you can't kind of really good at elaborating on stuff, that goes on and on, endless. So anyway, so introducing more complex subjects gradually, not trying to do something, immediately. Anyway.
Thank you. Yeah, Yui, please tell us. I know you maybe have some of those experience. What is the dumbest one for you?
Yeah, the dumbest mistake, and it's a little embarrassing, was that I actually built a GPU software or package on a CPU node. And during the compiling process or building process, there was no error or there was no loud warning sign that catch my attention. So after I built that, I directly delivered that model to the users, and the user was actually running it completely on the CPU node with no GPU acceleration. And after a while, there's one user actually submit a ticket telling me that the job was actually running much longer than expected. That until when I realized that it was built completely on the CPU node. So I think this kind of mistake is kind of embarrassing because I actually built it without testing it, and I completely trust my own how to say I I should not have done that because I need to test the software and never trust anything from the compilation output. And a clean compile doesn't mean anything. You always have to verify it. And that's the lesson I learned from my own dumbest mistake.
Good. Thank you. Thank you again. Now that we went through some of the dumbest mistakes, tell us about some of the smartest things that you did when you were learning and teaching research computing. So you is still you.
Okay, the smartest thing that I did is actually invest early in building a structured documentation website. So, for example, a lot of times that rather than letting the knowledge live in a scattered pieces here and there, I started building a systematic website covering a lot of information that I gathered from either from the ticket or start to actually building the get started guide to our users so that our users can start doing the self-service learning from the website. For example, I see one of the chat from Christopher. He mentioned that he's been using Slurm for a long time until recently someone introduced the as if command. And those kind of information we posted on our website. And recently, with the help of AI, we have the AI chatbot. So those little pieces of information that you can easily find from our website. So you don't have to waste a lot of time until someone tell you in the future, you actually can start searching and start learning from our own website. So that's something that I think is quite smart to build from the early, to build at the early period so that users can get benefit from it.
Yeah. Jason, what about you?
I think one of the best things to do, particularly at smaller institutions, is to emphasize, create, and enhance the community nature of the work. I think when researchers are so often used to working kind of in a solo environment, when you go to a more central resource, which, as others have pointed out, can sometimes strain under the demands, and people, if they could, would use all of it potentially, but it is a shared resource. I think reminding them in both subtle and very explicit ways that this is a community. These are community resources, and we rise and fall and benefit from all of this together. That was really helpful. So, creating advisory committees so that it doesn't, so that we give our researcher community a voice in the direction of, whether it's hardware changes or new services to offer or, whatever. Doing things like that, and really fostering that sense of community and community engagement, I think paid dividends over the long run, and really helped to have researchers and students get introduced to other folks who were doing either similar or dissimilar kinds of work, both of which have their advantages when you're networking and coming to understand the ways in which people utilize these kinds of services. I think all of that is very helpful and was a smart decision.
Thank you very much, Jason. Good answer. Bob, please tell us a little bit about yourself then.
Yeah, so I think one of the smartest thing I've done, which probably took me a couple years before I figured it out, but just keeping detailed notes when I work with the researchers. So I used to just get them going as quick as possible, give them their script, and then walk away. Um, but now um, more thoroughly. I do some sample runs, look at the performance, keep notes on the changes I make in the scripts. Then once I'm happy with a particular workflow, I'll actually keep a copy of that in my own space because the researcher often goes in and messes up all my good work. So, so after that happened a couple of times, I learned to keep my own copy. And uh, like you had mentioned, we are working on an internal chat tool for research computing, and that'll be a great spot to I can put a lot of my um, tools and scripts up there that should be able to help people in the future more easily grab and get them make them a little more independent.
Thank you, Bob. David, anything to add?
Yeah. Well, since the focus of this panel discussion is on teaching, I'll do an example from teaching. So running our workshop series, when I first started, I thought, well, I'll just kind of stay within our ecosystem and, created a web page with all our upcoming workshops. And then I would link out to forums. And of course, I had to create all the forms for registering. And then, I had to uh, copy people who registered, copy all their email addresses, put them into Teams. And then sometimes we'd have 2 or 3 workshops in a single week. And after every one of them, I'd have to go in and edit the web page. And, there were just kind of all sorts of updates that we had to do. And then somewhere during COVID, when we had a little time to sit back and reflect on life and work a little bit, we got very, um, I would say, developed a really good professional relationship with our university libraries team. And I saw how great their uh, their scheduling software was. You have templates for workshops, and the forms are all automatically created, and emails get sent out automatically. And at that point, all I had to do was, say, oh, date, time, duration, here's modify the text a little bit to update it out of the template and give it the link and the password to the Teams meeting that underlay it. And then I also didn't have to update our website anymore because I could just say, link out from our research computing website to the schedule of upcoming research computing sponsored workshops. And then as soon as a workshop's over, it comes off the view. It's just a simple URL. This there'd be weeks that when this would save me 10 or 15 hours a week just by having all this stuff automated. So I would say, that and really starting to use AI a lot in my work. for drafting things or prototyping solutions. As an example, so if I'm working on metrics for our workshops and I get some new spreadsheet format, now I just hand it to AI and say, here, make me a SQL create statement for this spreadsheet. And it's never 100% correct, but boy, does that save me a lot of trial and error. I'll modify a couple of fields here and there and, run it a couple of times and then poof, the data goes into the metrics database and suddenly I can query against it. So, yeah, I would say the smartest thing is like taking advantage of the technology and sometimes just stepping back a little and saying, well, how could I do this smarter? How could I do this better? How can I get more done with less work?
Yeah. Thank you very much, David. Sue?
So I agree with everyone's answers. I do build previously, I had a repository on GitHub for my teaching materials. I do expect students to read it before come to class. That saves me some of the teaching time, but then I realized they never read it. So, I cannot think of a possible way to force them to read it. So now in my teaching material, I create Jupyter notebooks with some possible job scripts and also possible way to work with HPC. I asked them to go through my Jupyter notebook, right? So I do like a lab session. I ask them to go through that first, and before I start teaching, more advanced stuff. So I feel like that's more effective. So I would say probably the lessons learned from here is to focus on reproducibility. So something that can be reused over and over. So now whenever I teach a new topic, I focus on something that I can put on the website so they can reproduce. And also the other thing I learned more effective is I built a peer mentoring system. So peer mentoring system is more effective because more advanced students are, I don't know, maybe to students' eyes, it's more approachable to talk with a senior student than talking with me. So I do encourage, I cannot force them, but I encourage them to do peer mentoring among students. So the very tiny little disadvantage here is the senior students are hard to find. They usually already have a job or they are not, busy with something else. So, but however, I found that to be a super useful mechanism.
Thank you very much. Brian, in 1 minute, can you summarize your own smartest?
Well, one thing I did was I embraced another thing we had to do was renewals, which is a totally different thing. We had to go out and we pay a lot of money for software, and IT has a role in that. And I embraced that and learned how to do a bunch of things I'm not comfortable doing. It involves like sometimes you got to schmooze a little bit with the reps. We pay them a lot of money and make sure everything comes down. Because if they go late, then their stuff stops working. So I totally embraced that process, and I think
Thank
that
you very
helped.
much. Thank you. Thank you. Just one person to jump in and ask this. What is the hardest one that you have ever taught or learned by yourself? The hardest. One person to answer this question for me. You can just unmute and jump in. I just want someone to tell me one hardest one.
When I was in grad school, I did assembly on the VAX. I think that was the hardest thing I ever did, but it was very, very, very profitable. It rewarded me greatly, but that makes me.
Thank you very much. Really, thank you for Brian. Thank you, Sue, Yui, Jason, Bob, David. I was very pleased, happy with the panel. It was a great panel. And I enjoy it with you all. And sending back to Henry. Thank you.
Thank you, Franklin. Thank you, everyone.
Thank you.
Thank you. Thank you. It was great.
All
Thank
right,
you.
thank you all, and let's give our panel a virtual round of applause, please. Okay, I'm going to stop the recording.